Imagine the entire universe concentrated into a single point smaller than an atom. This point contained all the matter and energy we see today. About 13.8 billion years ago, this point began to expand rapidly in a massive explosion. We call this event the Big Bang. The Big Bang was not an explosion in space but rather an expansion of space itself. It's hard to visualize, but imagine a balloon with dots drawn on it. As you inflate the balloon, the dots move further apart. Similarly, as the universe expands, galaxies move away from each other. This expansion continues today, and we have evidence to prove it. Scientists have observed that distant galaxies are moving away from us, and the farther away they are, the faster they are receding. This observation supports the Big Bang theory and the idea of an expanding universe. The Big Bang theory is the prevailing model for the early universe. It explains a wide range of observations, including the cosmic microwave background radiation, the abundance of light elements, and the large-scale structure of the universe. In the first fraction of a second after the Big Bang, the universe was incredibly hot and dense. As it expanded, it cooled down. This cooling allowed energy to transform into matter, according to Einstein's famous equation E equals mc squared. Initially, the universe was filled with a sea of elementary particles like quarks, electrons, and photons. Over time, these particles began to combine, forming protons and neutrons, the building blocks of atoms. This process, called nucleosynthesis, gave rise to the first light elements, hydrogen and helium, which still make up the majority of the universe today. As the universe continued to expand and cool, gravity started to play a significant role. Tiny fluctuations in the density of matter acted as seeds for gravitational collapse. Over millions of years, these regions of higher density attracted more and more matter, eventually forming vast clouds of gas and dust. These clouds would become the birthplaces of galaxies. The expansion of the universe is a continuous process. It's like a balloon that keeps inflating, carrying galaxies along with it. Scientists use various techniques like observing distant supernovae and measuring the redshift of light from galaxies to study the rate of this expansion. The early universe was a chaotic soup of elementary particles. As the universe cooled after the Big Bang, these particles began to combine. Protons and neutrons formed first. Protons have a positive charge, and neutrons have no charge. These protons and neutrons then came together to form the nuclei of atoms. The simplest atom is hydrogen, which consists of one proton and one electron. Helium, with 2 protons, 2 neutrons, and 2 electrons, was the next element to form. These two elements, hydrogen and helium, were created in abundance during the first few minutes after the Big Bang. They remain the most abundant elements in the universe today. Trace amounts of lithium and beryllium, the next lightest elements, were also created during this early period. The formation of these first elements was a crucial step in the evolution of the universe. They provided the raw materials for the later formation of stars, galaxies, and ultimately planets and life itself. Within the vast clouds of hydrogen and helium, gravity brought matter together. These clouds, called nebulae, became denser and hotter over time. As the temperature and pressure at the center of these nebulae increased, a remarkable transformation occurred. Nuclear fusion began. Nuclear fusion is the process where hydrogen atoms combine to form helium, releasing tremendous amounts of energy in the process. This energy release is what powers stars and makes them shine. The birth of the first stars marked a turning point in the history of the universe. Stars didn't form in isolation, they were born in clusters within galaxies. Galaxies are massive collections of stars, gas, dust, and dark matter, held together by gravity. The Milky Way galaxy, our home, contains billions of stars and spans over 100,000 light-years across. As stars live and die, they create and disperse heavier elements into space. These elements, forged in the hearts of stars, became the building blocks for planets, and eventually, life itself. Section 5. Our galaxy, the Milky Way. Our solar system resides in a giant spiral galaxy called the Milky Way. Like a majestic city of stars, the Milky Way contains billions of stars, along with vast clouds of gas and dust. Our Sun is just one of these stars, located about 26,000 light-years from the galactic center. If you look up at the night sky on a clear night, you can see a faint band of light stretching across the sky. This is the Milky Way, our view of the galaxy from within. The Milky Way's spiral arms are home to active star formation, with new stars constantly being born in these regions. The Milky Way is part of a larger group of galaxies called the Local Group. This group contains over 50 galaxies, including our nearest large galactic neighbor, the Andromeda Galaxy. Section 6. The formation of the solar system. About 4.6 billion years ago, a giant cloud of gas and dust, called a solar nebula, collapsed under its own gravity. This collapse led to the formation of our solar system. As the nebula contracted, it began to spin faster and flatten into a disk. At the center of this swirling disk, the sun ignited, becoming a star. The sun's powerful gravity pulled in most of the material in the nebula, leaving a small fraction to form the planets, moons, asteroids, and comets. The inner planets, Mercury, Venus, Earth, and Mars, formed closer to the sun where temperatures were hotter. These planets are rocky, with solid surfaces. The outer planets, Jupiter, Saturn, Uranus, and Neptune, formed in the colder outer regions of the solar nebula. These gas giants are much larger than the inner planets and are composed mostly of hydrogen and helium. Section 7. Recent discoveries with Hubble and James Webb. Telescopes. Space telescopes like Hubble and the James Webb Space Telescope have revolutionized our understanding of the universe. The Hubble Space Telescope, launched in 1990, has provided stunning images of distant galaxies, nebulae, and other celestial objects. Its observations have helped scientists determine the age of the universe, study the expansion of the universe, and discover new moons and planets. The James Webb Space Telescope, launched in 2021, is even more powerful than Hubble. It observes the universe in infrared light, which allows it to see through dust clouds and observe the very first stars and galaxies that formed after the Big Bang. Webb's observations are providing unprecedented insights into the early universe, star formation, and the atmospheres of exoplanets. Section 8. The future of the universe. The fate of the universe is a topic of ongoing scientific investigation. The current understanding is that the universe will continue to expand forever. As it expands, galaxies will move farther apart, and the average temperature of the universe will decrease. One possibility is that the expansion of the universe will continue to accelerate due to a mysterious force called dark energy. In this scenario, the universe will become increasingly cold and dark, with galaxies eventually becoming isolated islands in the vast emptiness of space. Another possibility is that the expansion of the universe will eventually slow down and reverse, leading to a big crunch. In this scenario, the universe would collapse back on itself, eventually reaching a state of infinite density and temperature. Section 9. Conclusion. Our place in the cosmos. The story of the universe is a tale of vast scales of time and space, of incredible transformations and remarkable events. From the Big Bang to the present day, the universe has been evolving, creating the structures and elements that make life possible. We are fortunate to live in a time when we have the tools and knowledge to study the universe and unravel its mysteries. Through the observations of telescopes and the work of scientists, we are piecing together the story of our cosmic origins. As we continue to explore the universe, we gain a deeper appreciation for our place in the cosmos. We are a part of this vast and ancient universe, connected to everything around us by the common threads of matter, energy, and the laws of physics.